All right, so today we're going to be doing the acid-base test review. You have your test tomorrow, and so we're going to go through and make sure we know how to do all the problems. The first problem is a pH problem. We're going to have a lot of these. And it says determine the pH of the following solution. So we're going to take out our handy-dandy formula chart, and it tells us that the formula for pH is pH is equal to the negative log of the H plus concentration. That'd be the hydrogen ion concentration in the solution. Okay, so we have first a 9 times 10 to the negative third molar hydrobromic acid solution. So if I'm looking at hydrobromic acid, it's a strong acid. That hydrogen is going to completely ionize. There's only one hydrogen in this formula, so that means it's a monoprotic acid. So I get to go ahead and plug directly into my equation, and I get pH is equal to the negative log of 9.0 times 10 to the negative 3. Now, the reason I decided not to just put 9 and to put 9.0 is because I'm going to remember my significant figure rules, which are also on your formula chart. So if I do the negative log of 9.0 times 10 to the negative third, I put that into my calculator, I get that my pH is equal to 2.1. Now, that's after I rounded it, of course, and there were two significant figures, 9.0. All the trailing zeros after a significant figure, if a decimal is shown, are significant. So I had two significant figures. I got two significant figures. Okay? My next one, letter B, says a 4.5 times 10 to the negative fifth molar potassium hydroxide solution. Now, this time, I'm looking here, and instead of seeing just an H, I see an OH. That means that my concentration is not going to be my H plus concentration. So I can look at this in two different ways. I can solve two different problems. I can first say that I could solve for POH is equal to negative log of 4.5 times 10 to the negative fifth. I could do that. And I would get my answer in POH, which is not quite what I want, but I can go from there to something else that I do want. If I do it this way, I'll get POH is equal to 4.4. And then I can use another formula that's not on my formula chart, but we learned it in class, and that was pH plus POH is equal to 14. Now, if I plug 4.4 in for the POH, so I get pH plus 4.4 equals 14, I can solve this equation and get pH is equal to 9.6. I think that's the most straightforward way of solving this problem. When I get to the end of this test, I'll show you another way, but I think this is probably the way that everyone is probably going to do it on the test. I could be wrong. Okay. Number 2 asks us, what are the POHs for the solutions in problem 1? So in problem 1, I started with pH, and I needed to get to POH now. So I have 2.1. Again, I can just plug it into my formula pH plus POH equals 14. So that'll be 14 minus 2.1, and I'll get 11.9, which in this case, since I only have two significant figures, is going to round to 12. Okay. Now, the next one, I can look at the equation that I already did, and I already calculated POH. So POH for B is 4.4. Okay. Now I go on to number 3. It says determine the pH of a 0.0034 molar HNO3 solution. So this is nitric acid. Again, this H is going to completely ionize since it is a strong acid. And we will just solve the basic formula. pH is equal to negative log of the H plus concentration, which if it's in molar, it's already there. So we just put 0.0034. Now, I'm going to look at my significant figures again here. If I got 0.0034, I look on my formula chart, it tells me that leading zeros are insignificant. They don't count, so I only have two significant figures. So when I put this into my calculator, I'm going to get a bigger number, but the actual answer is just going to be 2.5 as my pH. Okay? Now the next one asks me to determine to the pOH of a 0.0034 molar sulfuric acid solution. And it's a hint. This one is polyprotic. Polyprotic means that it can donate more than one hydrogen ion. So in this case, it's actually going to donate 2. So that means that instead of just doing pH equals negative log of this 0.0034, I'm going to multiply that 0.0034 by 2, since there are 2 hydrogens for every mole. So I get negative log, and I'll do 2 times 0.0034. Now, as long as you put that in your calculator exactly like that, you'll get the right answer. And you can do it in one step instead of having to multiply and then get that answer, and then do pH equals negative log of that answer. It's going to save you a little bit of time to keep it inside those parentheses. And what you'll get is pH is equal to 2.2. Okay? Well, this question didn't ask for pH, though. So what we're going to do is we're going to go ahead and change it. We're going to do, again, the pH will be 14 minus 2.2. So I'll get pH is equal to 11.8. Now, I made a mistake just now, and I just now saw it. But I started with 2 significant figures. That means I'm going to round this all the way to 12. Okay? I'm going to go to number 5. Number 5 says, determine the pH of a 4.5 times 10 to the negative 4th molar sodium hydroxide solution. Okay, so I'm going to look at this. I go 4.5 times 10 to the negative 4th. That's my concentration. This OH tells me that I'm dealing with a base, not with an acid, which also means that I can't directly calculate pH. What I can directly calculate is pOH. So pOH is going to equal the negative log of this 4.5 times 10 to the negative 4th. I'm going to put that into my calculator, and I get 3.3. That's my pOH. And again, we're going to get good with this formula. 14 minus 3.3 is going to equal 10.7, but I'm going to remember to round it correctly this time. It'll equal 11 as my pH. Okay. Now, always make sure that you're getting the right unit that goes with the question. So this one asked for pH. I calculated pOH and then went to pH. Okay. Number 6. This one's the little tricky one. It says, if a solution is created by adding water to 2.3 times 10 to the negative 4th moles of hydrochloric acid and 4.5 times 10 to the negative 6 moles of lithium hydroxide until the final volume is 1 liter, what is the pH of this solution? Okay? Now, this question has a lot of words in it, but don't let it confuse you. Okay? So we're going to basically be doing a dilution problem or a concentration problem, and we're going to be looking at this a little critically. Now, we've talked about how acids and bases react, so the HCl is going to react with the lithium hydroxide, and it's going to form 2 things. Well, first off, when an acid and a base react, they always produce good old H2O. And then the second thing that they're going to produce is a salt. In this case, it is lithium chloride. Okay? Now, what this shows me is that for every 1 mole of HCl, I'll use 1 mole of lithium hydroxide. Okay, so that shows me that in this solution, I'm going to react, and we're going to pretend it reacts completely, doesn't go backwards and forwards or anything like that. We're just going to react all that we have. So that means whatever we start out that had more, which in this case is going to be the HCl, we're going to use the HCl as much as we can, which is going to be limited by this part right here. Okay, so what we can do is we start with 2.3 times 10 to the negative 4th, and we're going to subtract out the part that we used, which is going to be 4.5 times 10 to the negative 6th. Okay, and what we're going to be left with is 2.3 times 10 to the negative 4th moles of HCl. Now, my pH formula does not have moles in it, but it does have concentration, which is molarity. So all I have to do now is divide this by my volume, which was just 1 liter. Makes it real easy. And I get my molarity. It's just going to be 2.3 times 10 to the negative 4th molar, capital M, HCl. Now I can easily calculate pH now. All I have to do is pH is equal to negative log of my H plus concentration, which is going to be 2.3 times 10 to the negative 4th. What I get is a pH of 3.6. All right. That one wasn't so bad. It seemed a little tricky, but we got through it. Number 7, this one's going to be a really easy one. Why would we say that a solution with an H plus concentration of 1.00 times 10 to the negative 7th molar is neutral? So all we have to do here is look at what our scale of pH is. Now, for our pH scale, we have some numbers. We have all the way to the left is 0. And all the way to the right is 14. And right smack dab in the middle is going to be 7. Okay, so if I do by pH on this, I'll get pH is equal to negative log of 1.00 times 10 to the negative 7th. And I get a pH of 7. Okay, so by what we've said, anything between 0 and a 7 on the pH scale is an acid. Anything from 7 to 14 is a base. But right in the middle, we're going to call that neutral. So why would we say that the solution of H plus concentration is 1 times 10 to the negative 7 molar is neutral? Well, because it has a pH of 7. So what we've said our scale is defines neutral to be 7. Okay. Number 8. What is the pOH of a solution that contains 45 grams of sodium hydroxide dissolved in 1.5 liters of water? Okay. So we have to break out our good old molar mass and molarity and calculate our concentration. Okay. So this is pOH is what we're looking for. And it is for something with an OH, so that means that's going to be a little bit easier. But first off, we've got 45 grams. And if you remember, or you look on your formula chart, to get to molarity, we need moles over liters. It says so on our formula chart, and that's what we're going to use for concentration. Now, I already have liters, so I'm going to go ahead and put that on the bottom. I have 1.5 liters. Now, this grams is the tricky part. I don't want grams. Grams is on top right now. That means I need to put it on the bottom. And I need to get moles on top. And there's something that we've been using for a while now that has the units of grams per mole, or grams divided by moles. If you flip it, it's moles divided by grams. And that's molar mass. The molar mass of sodium hydroxide isn't too hard to calculate. I have 1 sodium times its mass of 22.990 from the periodic table, plus I have 1 oxygen. I always write that 0 low so we don't think it's a 10, times 15.999, plus I have 1 hydrogen times 1.008. So I put those into my calculator and I add them up and I get a molar mass of 39.997 grams per mole. So all I'm going to do is, since that 39.997 is touching the grams, I'm going to put my number next to the grams, 39.997. And it's per mole, which is 1 mole. So I multiply straight across on the top. I get 45 moles divided by 1.5 times 39.997, and that's a wonderful number. It's 59.99955. Now, I don't round that until I get done. So I'm going to do 45 divided by 59.99955, and I will get 0.75 molar. Moles per liter makes molar. And this is, of course, talking about NaOH. Okay? Almost done. I just need to calculate POH now. And POH is equal to the negative log of the OH concentration, which we just calculated. It's 0.75. So 0.75, and we will get POH is equal to 0.12. That's our answer. All right, number 9. What is the difference between a strong and a weak acid? So the question that we have to ask is, what's the difference? What's the thing that changes between a strong and a weak acid? It's actually pretty easy. There's one way of saying it, is that a strong acid completely dissociates in a solution. So if I'm talking about hydrochloric acid, and it's inside of a solution, when it gets into that solution, it breaks apart, and you get these H plus ions, and you get these Cl minus ions. Now they're no longer together. They're just floating around as happy as can be inside of their solution. Okay? And my arrow only goes to the right. They don't try to form back together. As long as they're in that solution, they're going to stay separated. Okay? Now, we could have a weak acid. So if we're looking at hydrofluoric acid, it gets into the solution. It does almost the same thing. But we get the hydrogen, it's positive, and we get the fluorines, they're negative. But what happens is these hydrogens and these fluorines don't always completely stay apart. Sometimes they want to get back together. They want to go back and be hydrogen or hydrofluoric acid instead of just hydrogen and fluorine. So when that happens, we call this a weak acid. Okay? So this one's weak. This one's strong. It only goes one way. Okay? So how can I remember which acids are strong and which ones are weak? Okay, we have 6 strong acids that you're supposed to memorize, and we have a mnemonic device to try to remember it, CBS pen. So we have hydrochloric. That one's pretty common. We have hydrobromic. We have sulfuric. We have perchloric. We have hydrofluoric. iotic, and we have nitric acid. Okay? And it also wants the formulas, the names and formulas. So this is going to be HCl. This is HBr. Sulfuric is H2SO4. Perchloric is HClO4. Hydroiodic is HI. And nitric is HNO3. Now, sometimes people will mess up sulfuric acid because they'll think that H2S is the same thing. This is hydrosulfuric. And hydrosulfuric is not a strong acid. In fact, it's a weak acid. The hydrosulfuric acid will go back and rebond. Okay? Now, the way we can always remember is if it says hydro in front, that means it's just going to be an H and an element. So hydrochloric was H and chlorine. Hydrobromic was H and bromine. Hydroiodic is just H and I. All the others don't have hydro. That's a way to remember the difference. So please, please, please don't write the formula for hydrosulfuric on the test when you're writing sulfuric acid. Okay. Next up, would a substance with an H plus concentration of 1 × 10⁻13th molar be considered an acid or a base? Okay, so first off, we're going to go back and we're going to calculate pH again. So pH is equal to negative log, and our concentration is going to be 1.0 × 10⁻13th power, which gives us a pH of 13. So the way you can explain it is this is going to actually have to be a base because a pH greater than 7 is basic. Okay. Number 12 says, would a substance with a pOH of 6 be considered an acid or a base? So pOH is a little bit of a different scale. So for pOH, we have a scale where it looks also an awful lot like the pH scale, except it's backwards. So 0 to 7 on the pOH scale is basic instead of acidic. And from 7 to 14, it's acidic instead of basic. And 7 is still neutral. So a pOH of 6 would fall into the basic category. And if you draw out the scale, I'm going to count that as explaining your answer. Okay. Number 13, would a substance with a pH of 6 be considered an acid or a base? Again, you can draw out the pH scale and show me that 7 is neutral. Guess I should draw the arrows. This is acidic. And over here between 7 and 14 is basic. Okay. Now, the next question I ask is something that you can find right on your formula chart. What is the equilibrium constant for water? From the formula chart, K water is equal to 1 × 10⁻14. Okay. And it's moles squared over liters squared. Okay. The next one is also another one you can find on the periodic table, or not on the periodic table, but your formula chart. What's the formula for pH? We've been using it a lot already. Got to give you a couple freebies on the test, of course. pH is equal to negative log of the H plus concentration. Okay. 16, what's the formula for pOH? It's not on your formula chart. So you have to remember, it's just like pOH, except you're going to change to OH instead of H. What does the sum of pH and pOH have to equal It's another one that we haven't gotten on the formula chart, but we're going to be using it a lot because it's a lot easier. POH plus pH is equal to 14. Okay? And finally, it says, what formulas would I have to use to calculate POH if the H plus concentration is given? So, I have H plus, I would use pH is equal to negative log of H. I would take that and plug it into pH plus POH is equal to 14. I could solve for POH out of that. Now, I told you back, I think on question 2 or 3, that I'd show you another way that's not quite as easy, but it's still 2 steps. If you like algebra, you can do it either way. But there's a formula on your formula chart that says K water is equal to your H plus concentration times your OH minus concentration. If we have that, and we have the other formula that says K water is equal to 1 times 10 to the negative 14, we can make the equation H plus times OH minus is equal to 1 times 10 to the negative 14th power. Okay? If we've got H, we can plug it in, divide, and we'll get our OH. And then if we have OH, POH is just negative log of OH. Like I said, this is a little bit more convoluted. It's not quite as easy to do, but you can do that. This is my preferred method up here. All right, and that is all for the review. Hopefully y'all take some time, study tonight. You've been studying all last week. If you have any questions, feel free to email me, jeremy.larue@lifeschools.net, and y'all have a great day.